polygon with 30 points inside, such that no 3 polygon. Okay? And we have to find out the number of triangles formed in this configuration. Okay. Now, let us take a miniature copy of the problem. Suppose I have a rectangle and 2 points inside it, P and Q. Okay? Now, while forming the triangles, I have to cut the triangles, right? Okay? How? The question was, in how many triangles I can cut this such that the vertices of the triangle will be from this 130 points. Vertices of the triangle should belong to this 130 points, set of 130 points, correct? Okay? Now, if I, suppose I am trying to do this triangulation, okay, this is one triangulation, can I take another cut here?
No.
Is it allowed? No. Why? Yes, because if I do this cut, I am getting this extra vertex. So this cut is not allowed. So some of the student gave me answer 130, choose 3. Okay, this is number of ways I can select 3 vertices out of 130. Is it possible? No, this is not the answer. Because if I choose any 3 vertices, I will get the triangle, but I can't cut it along. If they would have asked the question that how many different triangles can be drawn, simply I have to draw. Then yes, any 3 vertices will give me a triangle because I have the condition no 3 are collinear. Correct? You have to simply draw any 3 would be. But now the problem is I can't choose any 3. It depends on the previous choice. So how to do this question? So I have 2 approaches for this. First approach is, suppose this is my 100 ball. Okay? First, initially insert one of the vertex, one of the point which are in the interior. Suppose P1 is inserted. Now this P1 will give me how many triangles? 100 triangles. We have taken 100 side, not 1000. Huh? Okay, 100 side. So it will give me 100 triangles, correct? So I can join it to all possible vertices to give me one triangle corresponding to each side, correct? Now let us insert second point. There are 2 possibilities. Either the point will lie here or it will lie in the interior of triangle, correct? Do we have 2 possibilities?
No.
Any other possibility? Huh?
No 3 are collinear.
No 3 are collinear gives you what? This is not possible. So any other point will lie in the interior of the triangle, correct? Okay. Now, so let us take any other point. Suppose it lies in this triangle. Now, how many extra triangles we will be getting? 1. Because originally we had this triangle and now we have cut it into 3. Correct? Okay. So now how many extra triangles are we getting? 2 extra. Because original triangle is lost. It got cut. Correct? So my P2 will give me 2 triangle extra. Correct? P3 will lie here or it may lie inside this triangle. Okay? How many extra triangle P3 will give me? 2. P4? 2. So on. So P30, each of them will give me 2 triangles extra. Correct? So total number of triangles would be 100 plus 2 into 29, that is 150. I am happy to say that many of the students have got the correct answer. They have discussed answer with you. Okay? This is one method. Everybody understood first method? Any doubt? Should I explain again? Any part? Everybody understood? Now let us see. This is a donkey counting method. Let us see some nice method to count this. Okay? I have to count triangles, correct? What we can say about the sum of all three angles of triangle? 180. What are we going to do is we are going to count all angles, and using those angles we will find out how many triangles are there. Okay? Now, so suppose there are n triangles. Suppose there are n triangles. Okay? So what will be the sum of all angles of these triangles? N into 180. N, can I write pi? Everybody understand? Okay? So n pi should be the sum of all angles. Let us find what is sum of all angles of a polygon with n sides. Yeah, or it is n minus 2 times pi. Okay? So it is, in this case it is 98 pi. Everybody know this formula? Yes. Is there anybody who doesn't know sum of all angles of a polygon? You doesn't know sum of all angles of a polygon? There is absolutely no process. Then it's somebody please adjust. Okay. Now see. So now to find the number of find this, what we can do is we can take a polygon, okay, take a vertex, okay, and join this vertex to all other vertices to form triangles, okay. Now clearly I can't join V1 to V2 and to V3, correct? So I will join it to all other vertices. So now how many triangles will be formed? It will be n minus 2 triangles, because I have joined this to n minus 3 diagonals, n minus 3 vertices. So I will get one extra triangle. I will get this extra. This triangle is, see, this is extra triangle. This is for this diagonal. Okay. Each diagonal will give me one triangle, and this is extra triangle. So totally how many triangles I am getting? N minus 2. So sum of the angles of a polygon is how much? So therefore will be n minus 2 times pi, correct? Okay. So now, so for my 100 ball, the sum of all these angles is how much? 98 pi. Is it clear to everybody now? Huh? Okay. Plus, I need to count all these angles at these points, correct? P1, P2, P3 till P30. At each point, how much is the sum of total of angles? 2 pi. 360 or 2 pi, correct? How many points I have? 30. So it will be 30 into 2 pi. So total will be 98 plus 60 pi. That is 158 pi. So my n should be 1. Okay?
Ma'am, can you explain it once more? The last part.
Yes. I'll explain it. See, pay attention. Okay? We were counting the number of triangles in this. For that, I claim that we should count the sum total of all angles. Okay? Because each triangle, the angle will be n pi. Correct? Each triangle, the sum of angle is pi. Suppose I have n triangles. angles, the total angle sum should be n pi. Okay. Now let's count this. What will be the total angle sum of the angles of polygon? That I know will be n minus 2 pi for n-sided polygon. We have 100-sided polygon, so that angle turns out to be 98 pi. Correct? Plus, at every point, what is the angle sum? 2 pi. How many points in the interior? I have 30 points. So it turns out to be 60 pi. So 98 plus 60 is 158 pi. Correct? So this equation tells me the number of triangle must be 158. Is that clear? This is how we can use geometry to count. Huh? Is it clear to everybody? Huh? Okay. See, each point gives you 2 pi. There are 30 points. Such that first one, no 3 collinear. Second one, no 4 concyclic. What do you mean by concyclic points? All 4 points lie on a circle. Okay. See, given 3 points which are non-collinear will form a triangle. So there is always a guarantee that we have a circumcircle to the triangle. But given 4 points, there is no guarantee that we have a circle passing through all 4 of them. If we have a circle passing through all 4 of them, we call them concyclic. If we don't have circle, okay, we just say, okay, that they are not concyclic points. Okay. Now, so if we have concyclic points, then we say that no 4 are concyclic. Then what we have? Then prove that there exists. Now this is a symbol of there exists. This is symbol for there exists. Is it okay if I use this symbol now? Yes. Now this is a mathematical symbol. Everybody can use this. Okay? In the exam. There exists a circle with three points on it, 1000 points inside and 1000 points outside. This we have to prove that there exists such a circle. Everybody is ready for solution? Now, for this solution, let us recollect the properties of arc of the circle. Suppose I have this angle on the circle and angular measure of this arc is 2m. What can I say about this angle? Everybody recollect this? Now, suppose I have angle inside. Suppose angle inside. This arc is of measure 2m. This arc is of measure 2n. What is this angle? And suppose I have angle outside. Okay. This arc is of measure 2m. This arc is of measure 2n. What is this angle now? Everybody remember this?
Yes.
Okay? Now. So, suppose I have a circle and this is my arc and suppose I have angles like this. suppose this is alpha, this angle is beta and this angle is gamma. What can I say about it? Which angle will be, are they equal or which angle will be greater? What can you say about them? Alpha will be greater than beta will be greater than gamma. How we can say that? Because we know alpha will be, suppose this arc is 2m, alpha will be 2m plus something, correct? Beta will be exactly 2m and gamma, alpha will be m plus some n, beta will be m and gamma will be m minus m, correct? Okay? So clearly alpha will be greater than beta will be greater than gamma. So I can say that the points that are inside the circle, they will subtend an angle greater than the points that are on the circle. Correct? Okay? And points which are in exterior of the circle will subtend the angle less than that are on the circle. This is how we are going to decide which point lies in the interior and which point lies in the exterior. समझ में आई बात? Followed? So when I can say that the point lies in the interior of the circle, if it subtends the angle greater than the angle subtended on the circle, correct? And the point will lie in the exterior if it subtends angle less than this angle. Okay? So let's encash this. So what we will do here, we have 2003 points. Okay? So I have a cluster of 2003 points. They are scattered anyhow in the general condition. Okay? Only restriction on them are no 3 collinear and no 4 concentric. Correct? Followed? They are in general position. I don't know anything about their position. Still I can say we can do this. Okay? So what we will do is, we will take a line. Okay? What we will do is, we will take a line which is extremely away from all these points, which is such that all the points lie on one side. That is possible because we have only finitely many points. Now slowly I will shift this line here. Slowly I will shift this line here till it meets first point. Very first point from my set of 2000 points. Okay, till it meets this. Then what I will do, if it happens that I have 2 points at the stretch are on this line, I am lucky. If not, I will rotate this line slowly till I get very second point. Okay? Followed? Everybody understood what I did? What was my aim is, my aim was to create a line containing 2 points from this set such that rest 2000 points are on same side. What I have to do, I have to create a line containing 2 points from the set. Everybody can see this figure comfortably? No. Can I clear this? Okay. Can I clear the question? This is my cluster of points. My aim is to create a line such that exactly 2 of my 2003 points lie here and remaining 2001 points lie on one side of the line. Okay? That is the aim. Now, how will I achieve this? What I have to do is, I have to shift one line, okay, from far away distance. I keep shifting till it meets first point. Okay? Suppose I am luckier, that line itself meets 2 points at a stretch. Okay? Then I am happy. If not, what I will do, I will fix this point and I will rotate this line till it meets very first point. B. Okay? Is the procedure clear to everybody? What I did? So what I have now? I have a line AB with 2 of points from my set of 2003 points on the line and remaining all 2001 points on the same side. Okay? will do is, for each of these points, P1, P2 till P2001, will calculate the angle, this AP1 will calculate the angle APIB for all I going from 1 to 2001. Okay? Followed? This will be some angles, correct? Okay? Now, we'll have to find out whether any two of these angles will be equal. Is it possible? My question is it possible that any two of these angles will be equal? Suppose this and this angle. Suppose these two angles are equal. Very good. If these angles are equal, what will happen? Suppose P5. Then these 4 points will become concyclic. Is it allowed? No. It is not allowed. So I can say that all these angles are distinct values. Correct? And there are some 2001 real numbers. That's okay. There are some 2001 real numbers. Right? So I can arrange them in increasing order. Theta 1, theta 2, theta 3. Correct? Theta 2001. Now my P1 might be theta 1000. Correct? They can be anywhere. Correct? So what I'll do, now let us relabel my vertices such that angle which is vertex which is making angle theta 1, let's call it Q1. Vertex making angle theta 2, let's call it Q2. Okay? Q2001. Is this much clear to everybody? What I did, firstly, we created a line such that exactly 2 points on that line, rest 2001 points on one side. Then we took all this angle APIB. Correct? Followed? Then we showed that no two angles can be equal. So I can arrange them in a sequence of increasing angles. Now the vertex which is making angle theta 1, let's call it Q1. The vertex which is making angle theta 2, let's call it Q2. So we are re-leveling the vertices. Why we are re-leveling? Because there is no guarantee that P1 makes angle theta 1. P1 can be a smaller angle. P1 can subtend a smaller angle. Is that clear to everybody? Now what I will do, take a circumcircle of triangle AP1001B. Let us take circumcircle of AP1001 and B. So suppose this is my point P1001. So suppose I consider the circumcircle like this. Okay? And this is making angle theta 1001. Okay? I consider this circumcircle. This is making angle theta 1001. Done. So my theta 1001 is somewhere here. Now let us consider any of these angles. Theta 1, theta 2. So this point is Q1001. Q1001. I'm sorry, we have relabeled it. Q1001. Okay? Now, so this is Q1001. Okay? Now, Q1 makes angle theta 1 which is less than theta 1001. So, angle Q1 is less than theta 1001. What can I say? Where Q1 must lie? Outside the circle. Q2? Outside. Q3? Outside. Q1000? Outside. Is that clear? What can you say about theta 1002? It is greater than this. So what can you say about 1002? Till theta 2001? Inside. Correct? So I have all these points outside and rest all these 1000 points inside. So this is the required circle which contains 3 points on it, A, Q1001 and B, and which point inside? Q1, Q2, Q1000, sorry, Q1, Q2, Q1000 outside and Q1002 to Q2001 inside. Is it clear to everybody? Very, very clear. I know this kind of proofs are very elegant. See, one of my best mathematician, Arthur Angel, has defined a good Olympiad problem as he said that an active mathematician and a school-going child are on equal footage in terms of knowledge. So the active mathematician should not have any advantage of his knowledge. Such a problem he has defined as a good problem. Let us see a good problem. Okay? Can I clear this now? This part at least. We have a chessboard. No, I'm not going to ask you number of squares. We can devote entire year on chessboard problems and beautiful chessboard problems. Still my chessboard problem won't get exhausted. Believe me. Okay? So chessboard is a very favorite of all Olympiad teachers. This problem, we have to color. This is a normal chessboard, 8x8 chessboard. What we have to do is we have to color each square by either say red or blue. Red or blue. Okay? I have to color this either by red or by blue. Each square. I have to color it in such a way that each row and each column has odd number of blues. Okay? See, there is no restriction on diagonal. There is only restriction in row as well as column. What is the condition? Each row and each column have odd number of blues. Okay? Rest, obviously an odd number of red, because each row and column contain 8. So if I have odd number of blues, red will be also odd.
So one whole diagonal through the...
Yes, that is one of the colorings. Very good. It was very fast. If I color one diagonal blue, then I will get each row has one blue and each column has one blue. So condition is valid. Now, is this the only coloring?
No.
Question is, find the number of good colorings. We call a coloring good if it satisfies the condition. Okay? Question is, find the number of good colorings. Okay? Everybody understood the question? See, if we color the diagonal blue So such how many different colorings? See, this is one coloring. Another coloring I can give you is this. I can color this 7 blue and I can color this 7 blue.
I'm 40.
No.
Okay? Followed? So first row has 7. Okay? Each other row has 1. Correct? So this is one color. Good color. Such how many? Sorry?
We can color one diagonal red as well.
Yes, correct. Okay? Question is how many total such colorings are there? Number of total good colorings.
Ma'am, so do we consider the other side as well? Like one diagonal then?
Sorry? Sorry? Just yes?
Ma'am, we consider the other diagonal as well, right? As another.
Yeah. See, if you consider this diagonal blue, that is one coloring. If you consider this diagonal red and rest both blue, that is other coloring. Other diagonals, that are other colorings. But these are not the only colorings. You can have random colorings. Okay? So how to count? Am I going to create colorings and count?
No.
Correct? See, we say that combinatorics is the art of counting without actual counting. So we have to count without actually counting.
Ma'am, can we use EX minus E raised to minus X by 2?
Nahi bachcha, generating functions won't be helpful here.
Okay.
Nahi, what he is trying to apply is correct, but unfortunately it won't be helpful here.
Total number of combinations kitne? No, the total number of combinations.
Can we use generating function? Let me think. But we'll have to use it over. See, problem is we have for generating function. Problem is we have two domains, rows as well as columns. We can use it only on rows or only on columns. Combination will be a problem. Are you getting me? Followed? For each row we can give condition. Condition will be very good. Very good. Now. Okay. So one way of making a problem easy is create a miniature version of the problem. Try to solve the miniature version, apply the logic to the original problem. So let's create a miniature version. My miniature version is this. Just a strip 1 cross 4. Now how many good colorings this strip has? 2. Some more. Some more. 8 is it? Why 8? What I'll do is I will color this part freely. Okay? And I'll keep one to adjust the parallel. I'll adjust this color, okay, according to, so that my condition is satisfied. So first I can color with either blue or red. Second I have again two options, blue red or red blue, red red. Third I have again two options, blue or red. Here also I have two options. Here are two options. So totally I have two options for this, two options for this and two options for this, 8 options. Now let us check how can I color the last one? Okay, I want to fulfill this condition that my blue should be odd. So what should be the color of last here?
Red.
Here?
Blue.
Here?
Blue.
Here?
Blue.
Red. Here?
Blue. Red. Red. Blue.
So how I have colored this? If I have odd number of blues already here, okay, then I'll color the last cell red so that odd number of blues are maintained. But if I have even number of blues here, I should color last cell blue, so I'll get odd blues. Is this logic clear to everybody? Okay, and why I have to multiply? First cell have two options, second have two options, and third have two options. Then why I am taking the product? Because for every option here, I have two options here. And for every options, four options here, I have two options. Correct? Is that clear? That's why I have to take the product. So answer is 2 cube 8. ये पक्का समझ में आया? Any doubt anybody? Huh? Now we have to apply it here. Okay? Here I have to apply it row wise as well as column wise. So tell me, how much part of my chessboard I can color free? 7 cross 7. Correct? So let's call it square A. Okay? Let's call this part B, rectangle C, and this is D. So this is a 7 cross 7 square A. Okay? So my A part is a 7 cross 7 square that I can color free. Can I rub the question? Now, so A part can be colored free. Okay? So what will happen once I color A? Which area color will be locked? C and B. C, because once I color A, B colors are fixed. I have to color each row such that every row has odd. So what is the criteria? How should I color? If I have odd number of blues here, I should color this by red. If I have even number of blues here, I should color it by blue. Correct? Everybody understood this? And C also will get colored same way. Okay? Column wise, I'll check. Okay? Each column should have odd blues. Now question arises, which color to be given to D?
Depends on B and
Depends on both. Whom I should give priority? To B or to C?
Both.
What if here I have odd number of blue? Sorry, odd number of blue. So I need to color this red. And here I have even number of blue then. We will prove that such a situation don't happen. We will prove that if I have odd number of blue here, then I have to get odd number of blue in C. Either I have, so we'll prove that if B has odd blues, then C also have odd blues. And in this case, I can color D with red, or B and C both have even blues and we can color D with blue. So basically my problem boils down to proving that the parity of number of blues in B and C is same. Parity means either both are even or both are odd. So what I want to prove now? I want to prove the parity of number of blues in B and C is same. Right? Okay? So let us say that number of blues in A, B, C be denoted by small a, small b and small c respectively. So what we have to prove? We have to prove that small b and small c are both odd, or small b and small c are both even. Small b and small c have same parity. In mathematical language we call it a parity. Okay? Is it clear to everybody? Now let us take a and b together. A plus b is equal. Let us think what is a plus b. A plus b means what? A is a number of views in square A, and B is number of views in this strip 1 cross 7. So A plus B I can say is number of views in first 7 rows. Correct? First 7 rows. Correct? Now in first row I have some number of views. I don't know exactly number, but what I know about it, it should be odd. So it is some odd number. In second row I have some odd number of views. Third row I have some odd number of views. So basically I can say this is sum of 7 odd numbers. Correct? Correct? This is sum of 7 odd numbers. Is this clear?
Ma'am, could you explain that ABCD one, the part of ABCD?
Yes,
Okay.
I'll explain. See, what we did is we divided the board such that first 7 cross 7 square is called A, this strip is called B, this strip is called C, and the last remaining square as D. Okay? Now, as per this logic, we know that A part can be colored freely. Okay? Then B will get colors according to this. How I have colored it. And C will get colored according to colorings of it. Correct? Okay? So I have to color D. So I will prove that B and C either both have odd number of blues or both have even number of blues, so that I can color D nicely. Okay? Colored? Is that clear?
Yes.
Now, so for that, let us take A, B, C, B, the number of blue squares in A part, B part and C part. Okay? Now what is A part and B part together? It makes 7 rows. A part and B part together makes 7 rows. So what is A plus B? It is sum of blues in first row plus second row till 7th row. Each is an odd number. So I can say A plus B is sum of 7 odd numbers. What can I say? A plus B, will it be odd or even?
Odd.
So I have A plus B is odd. Correct? Similarly, if I consider A plus C, it is sum of first 7 columns. What can I say A plus C? Odd, because it is sum of 7 odd numbers. Let's subtract. So what I will get? B minus C is odd minus odd? Even. Okay? So B is equal to C plus an even number. So if B is odd, what can you say about C? Odd. If B is even, what can you say about C? Even. So B and C have same parity. Correct?
Yes, ma'am.
Is that clear? Is it clear to everybody?
Yes.
So I can color my A freely by any coloring. Okay, the way I want. B's color, C's color will get locked, and so the color of D. Because if both B and C have odd number of blues, then I can color D by red color. Or if both B and C have even number of blues, I can color it by blue. Okay, this much is clear to everybody. So now the question arises, how many colorings I have? Which part of the board I am allowed to color freely?
A.
How many squares A has?
49.
So how many
2 raised to
colorings?
49.
2 raised to
49.
Because every square have how many options? Two options. So number of good colorings two raised to 49. Followed? Because for every square we have 2 options, and for every option you have another 2 options for other squares. You have understood why you have to type product? Followed? So we have 2 raised to 49 distinct colorings. Okay, forget about drawing such colorings. We won't even calculate this number. Followed? Okay? But impossible things can be done using mathematics. But this is what I call as a good problem. Because see here I have not used any difficult concept. All logical problem. But yet very difficult to crack. No restriction.
English medium से
Yes.
Lower number.
Sorry.
Lower number. Is it written lower or number?
Sorry. This is number. I can write n for the number. N is divisible by. Can I write n for the number?
But then the fourth condition is odd numbers and the third is
These are separate conditions. They are separate problems. These are separate problems.
8 to the power 4 into 2.
Yes. Shall we discuss now? Now, no restriction. For every place, we can have 8 options. So we have 8 raised to 5, correct? For no restrictions, correct? Because there is no restriction, so every number can appear at every place, correct? So we have 8 raised to 5 options, correct? Now, if the number is divisible by 5, then last place I can have only one option, 5, and rest, pin drop silence, please. Rest places you can have 8 options, correct? Why only one option? 0 is not there in my set. So this will be 8 raised to 4. Now third, divisible by 4. When the number will be divisible by 4? So let us try to find what are possible last 2 digits. Okay?
Ma'am, is it 8 to the
No. Now,
Ma'am, is it 8 to the power?
now, if I start with 1, 12 is divisible, 16 is divisible. If I start with 2, 24 and 28. If I start with 3, 36. If I start with 4, 44, 48, 50, 256, 64, 68, 72, 76, 84, 88. So how many numbers are there? 16. Okay? So I have 16 possibilities for n digits. Correct? And 8 possibilities for. So it will be 8 cube into 16. Correct? Followed? Yeah, 4 and 8 is there. Okay?
It's not 4 and 8 in the last page. So each of the other 4 boxes will have 8. So it will be 8 to 4 into 2.
2 minutes.
Can we just consider the last place to have 4 or 8?
Why? Why can't it have 1 or 2?
Ma'am, you can take it as 1 by 4.
Why can't it has 1 and 2?
Last is only the last.
But 12 ending with is also divisible.
14.
Now his answer is correct. See, he is saying that among any 4 consecutive number, one of them is divisible by 4. So I must see totally I had 8 into 8 option. Divided by 4, I have 2 into 8 option. But this will work. This works only because I have given number 1 to 8. If I would have given till 7, this would have not worked. So this is the safest method. This method will work in any case. Yes. Please go out of the class.
Can we?
You. I told you people not to talk. See, if you have to convey something more important than what I am doing, please come here and convey. Yes.
Can we taking 10th digit as it can, if it is odd number, then
Yes, correct.
unit digit.
Yes, it works.
Ma'am, last question answer. 8 raised to 4 into 4 plus 8 raised to 3 into 4.
Yes. Now odd numbers, rest all places I have 8 options. Last place I have 4 options. Which 4 options? 1, 3, 5, 7. Correct? And fifth. Now here, can I have a digit 3 at second place, thousandth place? Yes. Provided I have a digit greater than 4 here.
Yes, ma'am.
But suppose I have 4 here, then can I have digit 3 here?
No.
So my choice of the thousandth place depends on the choice of the previous 10,000th place. So I'll have to take options. What are the options? Options are that my 10,000th place, can I just write TH for 10,000? 10,000th place is 4 and my 10,000th place is greater than 4. That is 5 or 6 or 7 or 8. Okay? Now my 10,000th place is 4. Then what are options for other places? Now for 1000th place, can I have 5? Yes. Can I have 5 here? Yes. Because any other number if I put from this list, it will be greater than 45,000. Correct? So I can have here 5 or 6 or 7 or 8. So I have 4 options here. And this places I have 8 options. Okay. Now here at this place, thousands place, I can have freely any of the 8 options, because 10,000 place itself is 5 or 6. I need not bother for these places. So this will be simply 8 into 8 into 8 into 8. Followed? So total will be, it will be 4 into 8 cube plus 8 into 8 cube, that is 12 into 8 cube. Followed? Is that clear? Yes. I'll explain it. Oh sorry. 8 raised to 4. Yeah. So it will be 4 into 8 cube into 9. 1 plus 8. Now pay attention. Pay attention, I'll explain again. What I'll do is, I can take 10,000 place as 4, or I can take 5, 6, 7, 8. Okay? If 10,000 place is 4, then at 1,000 place, I can have options 5, 6 or 7 or 8. So there are 4 possibilities. And the rest places you can put any number. So there are 8 possibilities. Now if I take 10,000 place 5 or 6 or 7 or 8, then you can freely put any of the 8 numbers in. So totally we have 4 into 8 cube, and this 4 for 10,000 place. So this 4 of 10,000 place into 8 raised to 2. Correct? So then you can combine. Okay? Is this clear to everybody? Huh? Okay? Now, this we did when we are freely allowing any numbers. Correct? Okay? Now suppose I put a restriction that repetition is not allowed. Okay? Now we will have to solve each question for repetition is not allowed. Solve each question for no repetition.
कहाँ मिलता है इसका
No.
Including or not including.
So I'll give you 2 minutes to work on this and then we'll discuss.
Seven factor. Second factor. 7 factor. 7, 6, 5, 4. So we will be
Six, 7, 2, 0.
क्या किया
मैंने करा मैम 6720
Okay, shall we discuss now? No. First one. Now, first one here. No repetition. So, first place you can fill it in 8 ways. Now, we are using one digit. Correct? So, for second place we have 7 options. Now, 2 digits are used up. So, we have 6 options, 5 options and 4 options. Correct? Followed? Now, see the quantity n factorial is defined as 1 into 2 into 3 up to n. Okay? So, this can be written as
8 factorial by 3 factorial.
8 factorial upon 3 factorial. Correct? Okay? Now second will be, now 5 will go for last place. So you have 7 options. Second question, 5 is reserved for last place, units place. So we have 7 options for first place. We have 6 options, then 5 and then 4. Everybody understood why number of options are decreasing? Because we are using 1 digits. So it will be 7 factorial by 3 factorial. See this, I can write this as 7 into 6 into 5 into 4 into 3 to 1 upon 3 to 1. So that is 7 factorial by 3 factorial. Okay? Yes? Yes? Yes?
That is the last answer 6 factorial by 3 factorial into 32.
6 factorial by? No, there
3 factorial.
No, there will be options. Or last. You are talking about 5th?
Yeah, 5th one 6 into 5 into 4 into 4 plus 4 into 7 into 6 into 5.
There will be options. Now for third part, now here few of the options I will have to cancel. Which one? 44 and 88. Correct? Yes. So there are 14 options here. Now I have used up how many digits? 2 digits are used up. So I have 6 options here. Now I have used up 3 digits. So 5 options here and 4 options here. Correct? Because we have written 2 digits here. No? First we will fill these 2 digits. Okay? Is this clear to everybody? Okay? Now for odd numbers, units place have 4 options. Units place have 4 options. Now I have used up 1 digit for units place. So I have 7 options. Then I have used up 2 digits. So 6 options. 5 and 4. Correct?
Last question, like we have used all the digits, so like how 6 came first?
In the last one, third one.
Here, see, I have not used all the digits. See, at a time I can write all these numbers here. I am going to select one of the numbers and put it. Okay? Either I can write 12 or I can write 16. I can't write 12 and 16 both. Okay? So suppose I put 12 here. So I have used up how many digits? 2. So 6 digits are there.
For the fourth one, can we just divide the total number of combinations by 2?
Yes, here we can definitely. Because we have equal number of even and odd digits. Yes. See, last place, you can have only one option, 5. So one digit is used. So you can have 7 options here, 6 options here, 5 and 4 options. Number of options will go on decreasing. Correct? Now, last one. Suppose my 10,000th place is 4. Then, suppose my 10,000th place is 4. Then what I have? I have only one option for here. Correct? That is 4. So one digit is used up. How many options I have for this place? You can have 5, 6, 7 or 8. So you have 4 options. Now I have used up my 2 digits. Out of 8, how many digits are used up? 2. So how many are left? 6. 5. Now 5 and 4. Correct? Here, for beginning place, the 10,000th place, I have 4 options. 7. Now, any digits I can place here. But one of the digits is used up here. So you have 7, 6, 5 and 4. Is that clear? Very, very clear to everybody? You take product of these and then you add.
Ma'am, I couldn't understand it.
Yes, I'll explain again 2 minutes. See? No talking, please. See, here 10,000th place I have 1. Then, here 1000th place, 10,000th place you can put 4. Okay? So that is just one option. So for 1000th place, you can have only 5, 6 or 7 or 8. It should be greater than 4,500. Correct? So, you have 4 options here. So 2 digits are used up. So now you have 6 options. So now 3 digits are used up. So now you have 5 options. And 4 digits are used up. So now you have 4 options. Okay? And in this case, if the 10,000th place is greater than 4, you have 4 options, 5 or 6 or 7 or 8. So 1 digit is used up. Out of 8 digits, 1 is used up. So you have, pin drop silence please. So you have 7 options here. Okay? Then 6 options here, 5 and 4. Is that clear? Yes. Okay? Can I move on to the next concept? You want a break? Yes.
We need break.
क्या बात कर रहे हैं?
Ma'am, are you giving a break?
No. If you're hungry, you're free to eat without disturbing your neighbor and without disturbing. Okay? Okay? Suppose we have 100 people, okay? And we have to, how many ways we can make sit 20 out of them in a row? Okay? So we have totally 100 people. And how many chairs we have? 20 chairs. Okay? So, on first chair, how many options are there? 100. We have all 100 people can claim first chair. Now, first chair is filled up. Now, what are options for second chair?
Onwards till 81.
Till last?
81.
81. Correct? Okay? Now, so this is nothing but 100 into 99 up till 81. Yes. Correct? Now, but this is a very cumbersome number to write. So what we can do is, we can multiply by 1 into 2 up to 80 and divide by
80 factorial.
1 into 2 up to 80. Correct? Which will make it 100 factorial divided by
80 factorial.
Okay? See, pay attention. We had 100 people and 20 chairs. So why we got 80 here? It is 100 minus 80. 100 minus 20, sorry. Correct? Followed? Okay? Now pay attention. So when we have 100 people and we are making them sit 20 out of them. So what we are doing? We are selecting 20 out of them and arranging them in specific order. Correct? We call this 20 permutation out of 100. We call this
Permutation.
okay?
Could you explain what that means?
Yes. Permutation means selecting objects and rearranging them. So if we have a set of n objects and I have to select r objects and arrange them in specific order. Then I call it r permutations. Okay? Is that clear? What we did in the previous problem was, we found out the number of numbers where all 5 permutations from the set 1 to 8. What we did in previous problem were all 5 permutations of number 1 to 8. Is that clear? Very, very clear. So what we have calculated is the number of 20 permutation out of 100. Correct? Okay? Now let us try to find out number of r permutation out of n people. So basically, how many chairs I have now? I have r chairs people I have? N people. Correct? So first chair, N options are allowed. First chair, we have N options. Second chair, how many options are allowed?
N minus 1.
N minus 2.
N minus R.
N minus R plus 1. Because N minus R people will have to stand. Correct? Followed? See, N minus, there are only R chairs, so how many people will not be able to sit on the chair N minus R? Correct? So here plus 1. Here 80 people will have to stand, so last chair will have 81 options. Correct? Is that clear? So here the number of R permutations will be equal to what? That will be similar to this. So can I derive the formula here?
Yes.
100 will be replaced by N and 20 should be replaced by R. Correct? Okay. So number of R permutations, this we denote by this symbol NPR. We denote this by symbol NPR, and is what is the formula? N factorial upon N minus R factorial. Is this clear? Very clear. Okay. So please take down number of R permutations out of N distinct objects.
Ma'am, wait.
This is the symbol. Now tell me, suppose we have 100 people and 100 chairs. How many ways can we get?
100
Sir?
100 factorial.
100 factorial. Does it satisfy my formula? By definition, we define 0 factorial to be 1. This is by definition. Okay? It is defined like that. Okay? Huh? Now, so this will be 100 P100. That is nothing but 100 factorial divided by 100 minus 100 factorial, which is 100 factorial. Correct? Followed? Or sir, black. Or it could be, see, we have 100 chairs. First chair we have how many options? 100. Second chair 99. Third chair till 100 chair 100. 1. Correct? Okay. So it will be 100 factorial. Is this clear? Very clear. So I can say that number of N permutations of N objects is N factorial. Correct? Huh? This much is clear? Therefore, now let's see if we can. Beta, see, it is not assumed, it is defined. Why it is defined this way? As a reason. I can't explain it in this class. You can wait after class. See, anything in mathematics is a theory we have developed. It's a human-made theory.
But 1 factorial is also.
Yes. 1 factorial is also. Now, see, actually, in maths, it's not a material science. You don't have a chemical formula for 3 factorial. You don't have a chemical formula for a line. Nothing. It's our thought. Okay. We have defined theories. Now, how we develop theories? Theories will develop such that any definition in the theory should not contradict the earlier defined things. And that is how 0 factorial will be defined as well. So that it should not contradict such situation. Of course, there is a logic behind it, but I have not taught you that permutation combination, so I can't explain that logic. Just assume for time being. Actually, in mathematics, there is a concrete reason for each and everything. Whatever word I am uttering, I should be able to prove, because see, in mathematics it will never happen, because we have defined everything using concrete proofs and concrete proofs only. Followed? So it will never happen in mathematics that Newton's theory will be discarded by Einstein, because we don't assume anything. And there are few facts we have to take while defining the theories, but those facts are well defined such that they will not discard the previously proven theories. Followed? Unfortunately, now we have crunch of time, so I can't go deep into all this. I will just go exam point of view in this class. If you want such answers, you should attend my advanced lectures. Huh? Yeah. Can I clear this?
Yes,
Shall we discuss this? Now first is without restriction. How many? Yes. 12 factorial? Yes. There is no restriction.
Second is 5 factorial plus 7 factorial.
No, 8 factorial into 5 factorial. Second 5 factorial into 7 factorial. 8 factorial into 5 factorial.
8 factorial. Now see, first without restriction, so I have totally 12 people. We can consider them as 12 objects. They are all different objects, correct? So tell me whether if I change the order, definitely it will matter, correct? Okay, order is very important. Therefore, this I have to take permutation of 12 objects, and permutation of n objects is n out of n objects is n factorial. So this will be 12 factorial. Correct? Followed? Is this clear? Using formula, logically speaking, we have 12 chairs. First chair has how many options? 1 option, second chair, and so on. Till last chair, 1 option. So it is 12 factorial. Okay? Slowly you should start using the formula. Okay? Now, next. All boys are together. So we can imagine the boys as a single group. Okay? So we have a single group of boys and suppose girls are arranged like G1, G2, G3, G4, G5, G6, G7. Suppose consider one of the arrangement of girls like this. Now suppose I am arranging my boys like this, and if I arrange girls, I have not changed the arrangement. But if I change the arrangement of boys like B1, B3, B2, B4, B5, will it be the different arrangement?
Yes.
Yes.
Obviously yes.
Almost together.
Correct? If I change the arrangement of boys, though they are in a group, I can change the arrangement of boys. And it will be different arrangement. Correct? Followed? It will be different permutation. That means I'll have to consider the ordering inside the group also. And that will be how many ways? 5 factorial ways to arrange boys inside the group. Correct? Now pay attention. I have to place all boys together. So let's imagine this is a single object. You can't break them. Correct? So this single object along with 7 girls makes it 8 objects. How many ways are there to arrange 8 objects? 8 factorial ways. And for every such arrangement, how many ways I can change this arrangement inside? So what I have to do with this? Multiply. Is this clear to everybody? Is this clear? Why 8 factorial? Yes. Because 7 girls plus 1 group of boys will make it 8 objects to polynomial. Okay? Followed? So this can be done in 8 factorial. Now you will be able to do this problem.
Yeah, 6 factorial.
Try this. Yes.
The 7 factorial into 4 factorial into 3 factorial.
4th one, 3, 4.
7 factorial, 4 factorial, 3 factorial.
Yeah.
Please. 4th one. See, I am telling you, we have very limited time. In 2 lectures of 3 hours, I have to complete permutation. Entire combinatorics. So please cooperate. I won't be the loser if I am not able to cover it. 3 particular boys are together and 4 particular girls are together. So how many ways this can be done? 3 particular boys will form a group. How many ways the boys in this group can be permuted? 4 particular girls can be permuted. 4 factors. Now how many objects I have?
7.
See, out of 5, 3 boys are gone here. So I have 2 boys left. 2 boys and 3 girls left. Correct? And 2 groups. So totally how many objects? 7. So into 7 factors. Correct? Easy? Very, very easy. Now. Yes?
Can you please explain the 7 factorial, how the 7 factorial is?
Yeah. See, we have 3 particular boys in a group can be permuted in 3 factorial. Please keep quiet. 3 particular boys can be permuted in 3 factorial ways. 4 particular girls can be permuted in 4 factorial. Now we have left with 2 boys, 3 girls plus 2 groups. Totally 7 objects can be permuted in 7 factorial. Is this clear?
Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Zero. Oh, yes, because we just
No to boys.
Yes, this is zero. Let us change it to no to boys.
6 factorial into 7 factorial.
5 factorial into 7 factorial.
Please note
Wait, 6 into 7.
when the change no to boys are to do.
Answer. So 6 into 7 factorial into 5 factorial.
6 into
7 factorial into
8p5 into 7 factorial.
Sorry?
8p5 into 7 factorial.
Sorry?
8p5 into 7 factorial.
8p5.
8p5 into 7 factorial.
Yes, correct.
what is 8p?
Now no two boys are together. So what I'll do? First I'll make the arrangement of girls. Okay? Now suppose there are chairs kept alternately. Okay? So how many chairs will be there?
5.
Huh?
8 chairs.
Count. How many chairs are there? 8 chairs. Correct? So if I allow boys to sit on these chairs, obviously not two boys will be adjacent. Because even if suppose the boy sits here and a boy sits here, two girls will be adjacent. But the boys won't be adjacent. Correct? Followed? Now, so how many ways can girls be arranged? 7 girls? 7 factorial ways. And how many ways boys can be take this 8 places?
8p5.
Out of 8 places, I have to choose 5 for boys. So that will be 8p5. Correct? Followed? See, out of 8 places, I have to choose 5 places for my boys. And this is permutation. So out of 8 objects, I have to permute 5 objects. 8p5.
Can't we have it the other way around, like the boys are fixed and then there are chairs and there are girls?
No. That way girls won't be adjusted. Because here, see, look, if the boys are sitting here but no boy sitting here, then these two girls are adjacent.
Yeah.
Correct? Girls adjacent is other. Boys adjacent is not. So if you do reverse, boys might be adjacent but girls. Followed? Is that clear? Yeah, 7 factorial. Is this clear? Yes. Yes.
Now what if it says no two girls are together?
Yeah, here it will be 0 because boys are more less numbers. We need at least 6 boys.
Okay.
Okay?
How is the number of chairs fixed at 12?
Number of chairs are fixed. Followed? Is this clear to everybody? Huh? Pakka? Now we have seen about permutations, okay? That how to arrange objects. Okay? Now suppose I have to form a committee of people. Okay? Now suppose in the committee I choose this boy and this boy. First I chose this, then him and then him. Or first I chose him, then him and him. Will there be any difference in the committee?
No.
So there are certain situations where order of the objects is not important. Okay, only the choice is important. Okay, followed. Such situations are known as, that is only selection. Such situations are known as combination of objects. Okay, so suppose I have 10 boys. Okay, and I have to select 5 group of 5 boys. How many ways this can be done? I have to select a group of 5 boys.
10 factorial divided by 5 factorial.
Now okay. Now first let us find out the number of 5 permutations. How many 5 permutations will be there?
10p5.
10p5. Okay? But these are many more in number because here I am considering arrangement also. Correct? Followed? Now consider one selection. Consider one selection A, B, C, D, E. Now this selection gives rise to how many arrangements? This one selection gives rise to 5 factorial arrangements, or we can say 5 factorial permutations. So every selection gives rise to how many permutations? 5 factorial, correct? So total number of permutations are 10p5. So what will be total number of selections? This is a symbol of number of. This is a symbol of number of selections will be what? That will be number of permutations divided by 5 factorial, correct? That will be what? That will be 10p5 divided by 5 factorial, correct? Okay? Is that clear? Very, very clear. Why? Because in selection, see, because in selection A, B, C, D, E and A, C, D, E
Ma'am, can you explain it again?
Because in selection A, B, C, D, E and A, C, B, D, E are exactly same, identical, correct? So in the selection, all this permutation will give rise to a single selection A, B, C, D. Right? How many such permutations will give rise to single selection? 5 factorial permutations. Correct? Followed? So totally 5 factorial permutations will give me only one selection. Correct? So how many such selections will be there? That will be 5 permutations divided by 5 factorial. Is this clear now? Is it clear to everybody? Any doubt anybody here? So we define the number of combinations or number of selections is called the combination.
Ma'am, can you please explain that again?
Yeah. So we say that are combinations out of n distinct objects is defined as n choose r. This is nothing but, okay, let me write number of selections of r objects out of n objects. That is nothing but we defined as n CR, n choose r, and that will be nothing but NPR divided by R factorial. Correct? What is NPR? We know n factorial upon n minus R factorial. So now into R factorial. Now this has another way of writing. We write it like this. Okay? Now let me explain this once again. See, suppose I select 5 objects out of 5 boys out of 10 boys. Okay? Now, suppose I permute each group. Suppose I permute A, B, C, D. How many permutations will be there? 5 factorial permutation. Suppose I select E, F, G, H, I. How many permutations will be there? 5 factorial. For each selection, I'll get 5 factorial permutations. So total number of selections, okay, total number of selections will be what? Total number of permutations divided by 5 factorial. Correct? Is this clear? Who has this doubt?
Yeah. Yes, ma'am.
Is it clear?
Yes, ma'am. Yes.
Very good. Okay? Followed? Please take down the formula.
Ma'am, when to decide that we have to select the object?
See, you take down this formula. This is not enough. Okay, now, so how to decide when I have to do selection or when I have to do permutation? See here, permutation arrangement, we do arrangement. Means what? Means order between the elements is important. And if there is no order, okay, then it is called a selection. Okay, so here suppose I take a set of 3 elements, then ABC, ACB, BAC, BCA, CAB, CBA. All these 6 permutations will lead to only one combination A, B and C. Correct? Is that clear? So here, if we are selecting objects where order is not important, then we have to take combination. And if we are selecting objects and order is important, order of the arrangement is important, then we have to take permutation. Is this clear? Formula for R combinations out of n objects is n factorial upon n minus r factorial into r factorial. And formula for R permutations out of n object is n factorial upon n minus r factorial. Therefore, NPR is r factorial times NCR. Is that clear? Very, very clear? Because each combination leads to r factorial permutations. Followed? Here one combination leads to 3 factorial 6 permutations. Followed? Is it very clear? Please note this down and try to understand this. Can I clear this?
No, ma'am.
Now suppose we have 1000-sided polygon. Find the number of triangles that can be drawn. We are drawing, we are not cutting now. We are simply drawing. Such that the vertices are vertices of the polygon. Out of 1000, we have to choose 3. Any 3 will form a triangle because no 3 vertices of a polygon will be collinear. Correct? So this is simply 1000 choose 3. Easy? Followed? Huh? No. Yes, I'll explain. Yeah. I'll just give second problem and next. See, on this sides of this triangle I have drawn some points, extra points. Like on BC I have drawn 5 extra points, on AC I have drawn 4 extra points, on AB I have drawn 3 extra points. Now I have to find out the total number of triangle formed using this 5 points, 4 points, 3 points and ABC. Okay? Huh? Followed? Find the number of triangles that can be formed using all these points.
25 choose 3.
25.
3 plus
15 choose 3.
15 choose
Think. ABC.
Ma'am,
Yes.
15C3 minus 5C3 minus 6C3 minus 7C3.
Now here, let me explain this. See, we have 1000-sided polygon. So no 3 points are collinear. Correct? So now, out of 1000 points, I can select any 3 points to form my triangle. Okay? How many ways it can be done? The order of triangle, is it important? Because triangle ABC is same as triangle ACB, correct? These two are same triangle. Order is not important, means I have to take combinations or permutations. So 1000 choose. Easy? Easy? Followed? अरे पॉलीगॉन कैसे बनेगा? Okay? I'm assuming it's convex polygon. Okay? Huh? Next.
63 minus 63 minus 63 minus
Can I clear this? Okay. Are you all ready for second solution?
Yeah.
Now bear it. We have how many total points? 15 total points. Okay. Totally we have 5 plus 3 plus 4. Total number of points are 5 plus 3 plus 4 plus 3 vertices. So totally we have 15 points. So if none of the 3 points would have been collinear, suppose no 3 points would have been collinear, I would have got how many triangles? I would have got 15, choose 3 triangles. But unfortunately, these 7 points are collinear. So how many triangles these 7 points will form? 0 triangles, correct? But I'm counting here 7 choose 3 triangles, correct? So those 7 choose 3 triangles I should subtract. So it will be minus 7 choose 3 because they will form no triangle, correct? Similarly, these 5 points I should subtract and these 6 points I should subtract. Sorry, 6 points. 4 plus 2. Okay? Is this clear to everybody?
Yes, ma'am.
Okay. Now see, in pre-RMO, you will have to calculate the answer. But answers will be calculable. Okay? Right now, the problems which I am giving, I am not mentally calculating. I am just theoretically giving problems. So answers might not be too much. Okay, so we'll leave it till here. We won't do the calculation. You will be able to handle calculation part?
Yes,
everybody has followed the formula?
Yes.
See, remember, in final RMO, you can keep answer like this. Their only thought process is to be checked. So you can leave final answer like this. Many answers are very dirty calculations. We don't calculate things. They just think our thinking, they just check our thinking ability, not the calculation skills. Okay? But in pre-RMO, unfortunately, you will have to calculate.
The first one is 63C4.
63C4.
63C4. There are 63
Achha, if you select any 4 points, you will get a rectangle.
No.
So can I say 63C4?
No.
No. See, unfortunately, we can't select points to get the rectangles. You understood the difficulty. What he tried is, he counted it perfectly. See, we have how many lines here? Let me label it as L1, L2, L3, L4, L5, L6, L7, L8 and L9. And suppose this I call it B1, B2, B3, B6, B7. So 9 7s are 63 points, correct? So will answer be 63? Choose 4. Because if I take this point and this point and this point and this point, definitely I am not getting a rectangle. Can you see that? So how to find number of rectangles?
Ma'am, 9C2 into 7C2.
Sorry?
First one. 9C2 into 7C2.
See, obviously you have some formula. Okay? You used to use some formula to count number of it. Somebody was telling me when I just said the chessboard. But we'll see some nice method to count this. Okay? So what to do? See, to form a rectangle whose sides are parallel to axis. See, I have drawn my grid such that sides are parallel to axis. To get a rectangle, or even if it would have been parallelogram, okay, if my sides were not parallel to axis, but these lines were parallel and these lines were parallel to each other, then I need two lines which are parallel to each other and which are horizontally two horizontal lines and two vertical lines. Correct? For a case of rectangle. Correct? So two lines parallel to x-axis and two lines parallel to y-axis. How many lines I have parallel to x-axis? 7 lines. Okay? So I need how many lines? 2 lines. Correct? Does order matter? Which line I choose first? Order doesn't matter. That means I have to choose 2 out of 7 lines parallel to x-axis. So lines parallel to x-axis can be chosen 7 choose 2 ways, and lines parallel to y-axis can be chosen in 9 choose 2 ways. For every such choice I have so many choices. Suppose I chose B1 and B2, then L1, L2 will give me one rectangle, L1, L3 will give me another rectangle, and so on. Correct? So what I'll have to do? I'll have to take product. 9 choose. Followed? Is this clear? Easy? Followed? So it would be what? Without restriction, it would be 7 choose 2 into 9 choose 7. Okay?
Ma'am, why did you take the product?
Yeah. See, for every choice, suppose I take one choice from here. Say B1 and B2. One pair. For B1, B2, I have 9 choose 2 options of vertical lines. B1, B2 will give me 9 choose 2 rectangles, correct? B1, B3 will also give me 9 choose 2 rectangles. So each of the choice selection here will give me 9 choose 2 rectangles. Understood?
Yes, ma'am.
So I have to take product. Followed? Now number of squares?
7 choose 2 into 7 choose 2.
131. 134.
Tell me the method.
7 choose
You have not calculated.
8 into 6 plus 7 into 5.
Yes.
134.
Now pay attention. Now number of square. Now for that I'll find 1 cross 1 unit square. Okay? How many 1 cross 1 unit square will be there? 8 into 6, 40. Okay? Now 2 cross 2 unit squares. Let us find out how many 2 cross 2 unit squares will be there. For that, everybody is ready for 2 cross 2? Pay attention. How many 2 cross 2 squares will fit in one row? 1 cross 1. How many are fitting?
Not 4, 7.
7. See, you can have 1, 2, 3, 4, 5, 6, 7. Correct? Followed? And vertically how many will fit? 5. 1, 2, 3, 4, 5. One less than that of 1 cross 1 each. Correct? So there will be 7 into 5. 1 less than this. Correct? Followed? 35 squares of size 2 cross 2. Correct? So how many for 3 cross 3?
24.
6 into 4, 24. And 4 cross 4? 3 into 5.
4 into 2.
4 into 2, 8. And 6 cross 6, 3 into 1, 3. See, this is the largest size of the square. Because my breadth is 6, you cannot have the square greater than size 6. Correct? So, sum of these, correct, will give me the desired answer. What is the sum? 130. Yes. See, 2 cross 2 is bigger than 1 cross 1. So, you can't start. See, 1 cross 1 square, I can start from line 8 and go till line 9. Line 8 and line 9. But 2 cross 2, I can't start with line 8, it will go outside. So, my beginning line could be line 7. I can start from L1, I can start from L2, L3, L4, L5, L6 and L7. I can't start from L8. Correct? So, there will be only 7 squares along the row. Similarly, here I can start from B5. But I can't start from B6. So, there will be only 5 squares along the column. Is the concept clear to everybody? Huh? Is that clear? Unfortunately, this doesn't have a direct shortcut. You have to do it this way. Donkey Kong.
Then ma'am, actually if we are given, like for example, any question which has n points on the y-axis and y on m on the x-axis.
Summation, beta, summation. What is this?
And then we do that.
Sigma L minus I into B minus I going from what to minima of LB. Can you see that?
Yes.
Huh? I from 0, sorry. From 0 to minima of LB. Now rectangle with odd area. Why? What is area of this rectangle line? Square is also a rectangle with area 1 unit. So we have already 48 squares.
Could you explain the first answer?
First answer. See, for a rectangle, we need pair of vertical lines. Okay? So there are 9 vertical lines. Correct? I want only 2 of them. How many ways it can be chosen? 9 chosen. And horizontal lines we have 7. 7 chosen. No. See, the number of odd square itself is more than that. Okay. Number of odd square is. This is odd. This is odd and there will be more. For example, this is a rectangle of area 15, which is an odd rectangle, but it is not an odd square.
240.
How you calculate that?
I got 8 plus 6 plus 4 plus 2 plus 6 plus 4 plus 2.
Achha, like that. Okay, I don't know whether the answer is correct. I have not calculated. I will show you. Now,
all the permutation, all the combinations.
Let us see. See, I have a very good method for this. This is my own method. See, for odd rectangle, for odd area, I need both length and breadth odd. Okay. Suppose I first let us fix one line. Okay. First L1 is fixed. To get an odd length, what should be my second line? Either L2 or L4 or L6 or Ln. Correct? If I take any of these L3, L5, L7, I'll get even area. Correct? I'll partition the set of lines as A is equal to L1, L3, L5, L7, L9 and B as L2, L4, L6, L8. Clearly, if I choose any two lines from the same set, the breadth will be even. Correct? Any two lines from this set, again breadth will be even. Correct? So to get odd breadth, I have to select one line from A and other from B. Understood? If you select any two lines from the same set, your side is going to be even. So to get odd side, I have to select one line from A set and one line from B set. Okay? So the number of odd breadth is equal to this has cardinality of A is 5 and cardinality of B is 4. So 5 into 4, that is 20. Correct? See, what I have done is I have put alternate lines. Pay attention. I have put alternate lines in these groups. Cardinal number is number of elements of the set. Huh? It is denoted by this. See, I have put alternate lines in the groups. So if you choose any two lines from the same group, you are bound to get even breadth. So I have to select one line from A group. There are 5 lines here. So I have 5 options. And one line from this group, so I have 4 options. Now I should ensure my length is also odd. So same thing I will repeat for length. So C set will be B1, B3, B5, B7 and D set will be B2, B4, B6. So number of odd lengths is equal to 4 into 3, 12. So total number of odd rectangles for each of 20 lengths you have 12 options. So 20 into 12, that is 240. Is your answer correct? So what is number of rectangles with even area?
7 choose 2, 9 choose 2
minus. Yes, beta.
The number of rectangle even area would be 5C2 plus 4C2.
Yes.
Okay.
Yes, correct. Correct?
Ma'am, it would be 5C2 plus 4C2, the whole into 3C2 plus 4C2.
5C2. अच्छा.
Plus 4C2.
हाँ.
The whole into 3C2 plus 4C2.
Yeah. Correct. Perfect. What he is saying is, see, either we can count it this way, total minus rectangles with odd area, or no beta, you have counted the rectangle with area divisible by 4. You have got both length and breadth both even.
Yes, ma'am.
No.
Yes, ma'am.
So you have to use this. Huh? What he is trying is, he tried to use both length and breadth even. Followed? But even if length is even and breadth is odd, you will get rectangle with even area. Correct? So So it's better. So this is the only way to count. Is the logical?
Also do, for example, find even length and taking breadth.
Yes, that can be. That can be. That can be. Okay? Is this clear? Huh? Is it?